Hi everyone. For this question, it said the position vectors of the points P, Q, and R are given respectively as below. So from here, it means that OP is equals to vector P, which is 4, 3, 11. Meanwhile, OQ equals to vector Q, which is negative 2, 0, 8. And then OR equals to vector R, which is 1, 2, 0. Then for the first part of the question, show that PQR is a right angle triangle and calculate the area. So if PQR is a right angle triangle, we means that the vector of QP and the vector of QR, they were perpendicular. So to show that, we need to find out the vector from Q to P. To get vector Q to P, it will be QO plus OP. So QO and OQ, you can see is in opposite, so the vector will be negative. Then we find out the vector of QR, it will be QO plus OR. So QO and OQ opposite direction, negative vector. So with these two vectors, we're going to prove that they are perpendicular. In order to prove the perpendicular, we need our dot product where QP dot with QR. We see can we get the result of 0. If we can get result of 0, means they are perpendicular. So to do this dot product, x time with x, 18, y time with y, positive 6, and then z time with z. So we can get this 0, which means that QP and QR, they are perpendicular. So therefore, we write back the conclusion where we can show that PQR is a right angle triangle. Then for the second part, we're going to find out their area. So to find out area of a triangle, it will be 1 over 2 vector A cross with vector B and then find its magnitude. So from here we can get vector A as QP cross with vector B as QR. So we find out the cross product here where QB cross with QR. First row is IJK. Second row will be QP, which is 633. Third row will be QR, which is 3, 2, negative 8. Then we do this determinant 3 by 3. It will be minus I, minus j, then minus k. So to get minus, eliminate first row, first column. 3, 3, 2, negative 8. 3, negative 8. 3, 8 to the second minus. Then 3, 2 to the last minus. Then we see vertically here is 6, 3. Then we do AD minus BC, so negative 24 minus 6, 30i negative. Then this one negative 48 minus 9, negative negative become positive 57j. Then this one 12 minus 9. Then to get the area of the triangle, it will be 1 over 2 magnitude of QP cross with QR. So magnitude it will be x squared plus y squared plus z squared. If you don't want to write our answer in decimal, or you can put it as 3 over 2 third 462. Then we continue for question B. Find the equation of the plane that continue PQR. So we know equation of this plane which continue the point of PQR. So for plane equation formula, it will be R dot N equals to A dot N. So we need to find out what is our N. The normal vector come up from the plane. Since we have QP cross with QR, QP, when we crossing with QR, we can produce a normal come up with the plane. So this normal is negative 30i plus 57j minus 3k. Then vector here, A here, is represent the position vector for any point in the plane. So we can use point P, or we can use point Q, or we can use point R. So any position here. So we just pick one. So I will pick the easiest calculation, which is the point of R, 1, 2, 0. Then we put in into plane equation, where R we substitute as x, y, z, and negative 30, 57, negative 3. Then position vector of a point, 1, 2, 0, normal, negative 30, 57, negative 3. Then we do this dot product, x times with x, y times with y, and z times with z. Then you can notice that our equation here we can simplify. We can divide all this by negative 3. So here we have 10x minus 19y, then plus z, then negative 28. So this is our equation of the plane. Then for question C, find the parametric equation of the straight line passed through the point and perpendicular to the plane which continue PQR. So now we are going to find out a line. So this line is passed through the point and is perpendicular to this plane. So this line is perpendicular to this plane, pass through the point of 3, negative 5, 2. So for question C, to build a line equation, the formula it will be R equals to P plus TV. P is a position vector where the line passed through. So for the line passed through this point, so the position vector for this point will be 3i minus 5j and then 2k. Then we have to identify out what is our V. V is our direction vector. So we can notice that direction vector for this line is same with normal. They point to the same direction, which means that this V is negative 30, 57, and negative 3. So to find this line equation, the form of equation that we want is parametric form. So parametric form, it will be starting x equals to x naught plus tv, y equals to y naught plus tv, and so on. So therefore, x will equals to the coordinate. The point coordinate here is 3 plus tv, negative 30. And then for y, the point is negative 5 plus t, the v is 57. And then for z will be 2, then plus t, v, negative 3. So as I simplify this line equation in parametric, it will be 3 minus 30t. Then y equals to negative 5 plus 57t. And then z equals to 2 minus 3t. So, alright, so we have a small mistake here where this one is positive 3, so we recorrect it. So this is positive 3 square. Doesn't affect after we square, we're still having the same number. So when we come to here is positive 3. And if divided by negative 3, we get negative. So for this part, time with 0 will not change anything. Then for this one is positive 3. So lastly, the parameter will be 2 plus 3t.